Thanks for the intro. Um, yeah, just to give some context, so I want to make sure the session here is hands-on. I'm actually going to jump straight into some screen share, and I'll show you guys what we're working on. Okay, so I'll start here and just make sure everything's configured the way I think it should be. Always need to move the toolbar. Great. So, maybe one thing we can do is before we get started, I want to make sure there's going to be a bit of setup, right? Part of it is just having this notebook. So I believe one thing I can do is give people a copy that you can follow along with and download on your end. So let's do this. That's anyone with the link, and I'll let you guys view. This should let everyone, and I'll drop it in the chat now. This should let everyone be able to download. Maybe one thing, because we're going to get lost in the million chats being dropped in. Could somebody just ask a question in the Q&A? I was trying to ask it myself, but I guess panelists can't ask it. If somebody could ask a question, what is the link to the notebook? And I'll answer that with the link, and that way it just kind of stays there. There's a specific Q&A way to do this. There we go, Q&A. Okay, cool. I think we're good. I see Sandeep was the first one. Oh wow, that's a lot. Okay. I like the enthusiasm. Type answer. I'll send it here. Send. And can everyone check that the Q&A, the single answered one, has the link? You can access it. You can see the notebook. Now, you shouldn't be able to run or change anything, but what you can do, and let me just see, yes, can access. Perfect. That's great. What you should be able to do is just maybe make a copy. So save a copy or download it yourself and then upload it. If you like to work locally, that's fine. Actually, I don't really love Colab, but it's nice for sharing across different people. Maybe if you use Cursor, so I have the same notebook locally on my end, maybe that's your preferred setup. That's totally fine. So I'll start with making sure everybody's set up. What is the link? Can't see link to the notebook, can't see the link. I wonder if Q&A is, and again, please navigate to the Q&A section of the Zoom. I'll answer a few more. Works for me just fine.
Yeah, not everyone may want to may see the Q&A.
Oh,
Maybe you can check it
yeah,
out.
I'll put it in the chat, and
Yeah.
I don't know if there's a way to pin it. Um, but we do have 2 hours, so I just want to make sure everyone is the setup. All right, again, notebook for this workshop.
I mean, we are running that in YouTube live too. If you have problem with Zoom, you guys can use YouTube too.
Yep. Now, you don't also need the notebook. It's if you want to follow along and tinker. I actually would like for people uh, to be writing code. There's parts where we're just going to take a small break and individually work on some things, experiment with some things. Agents is all about just trying it yourself and doing experimentation. So I do hope people can, but it's not mandatory. You'll still learn a ton just watching and following along. Cool. Maybe I'll give it one more minute. And it seems like most people have it. Great. I'll periodically check the chat. Um, Sometimes I forget, but keep me honest if not. So while people set up, maybe I can do a bit of a setup of kind of the agenda for this workshop. So as you guys can see, we have a bit of a notebook here. Um, okay, so the premise is, beginner's guide. So I'm not going to go into crazy advanced things. but there are advanced sections that actually haven't completed. I'm planning on us completing them together in the workshop, right? Maybe an agent to do EDA on a notebook, an agent to actually write the Google Sheets. I'm curious to see what that's going to be like. But one thing I could ask is in the chat, and everyone feel free to just write their own answer. What is an agent, right? Probably the word of 2025 is agents, AI agents, agentic workflow. What is an agent? What does that mean to anyone? Okay, seeing some good answers or yeah, diverse and interesting answers. I always like to ask the question because at this point I find there's not really a definition. It's kind of just a vibe, right? I think a lot of people are getting to the point where it's automated, some type of automated decisions that has agency, it can do things automatically, uh, which I think gets to the point of it. Hopefully, what you'll see is under the hood, and one of the things we'll go through, it's really just an LLM. Like the engine of an agent is an LLM, like what's under the hood of ChatGPT and all these other LLM providers. But providing the LLM the ability to, you could just say, uh, access tools, to run tools, uh, to change its environment, and so on and so on. So let's see how that evolves as we go through the notebook session. And I'll do a quick check again. Perfect. And maybe quick vibe check. Who has actually built and ran their own agents before? Just so I get an idea of experiences people are coming from. And the expectation, by the way, of the workshop is not that you've done that. If it's really like that you actually haven't done that. This is very relatable. I tried it, but kept running into errors, so I gave up. Yeah, sounds about right. Cool. And I see people are using some agent, I guess I would call them SDKs. I did it using OpenAI, but my free credits finished. That's very relevant to what we're going to do now because we're going to use OpenAI. OpenAI actually a few months ago released an agents SDK. SDK just like abstractions to easily build agents because you could do it at the most granular level, which I'm going to show in this bullet point 6. Or you could just let some library, pip install something and it kind of handles all of the plumbing under the hood for you and you have no worries. Okay, work with people that use LLM, not myself. Okay, cool. So let me just walk through the agenda and then we'll do a little bit less setup and then we're gonna dive into just running code, right? I want to just go into what are AI agents, why should anyone care, right? Some core components, and then we're just gonna jump into actually running them and setting them up. The biggest assumption of the notebook is you have an OpenAI API, which is definitely a big assumption. So before we go any further, I want everyone, if they're actually interested in following along with the notebook, to try out this quick start to sign up for OpenAI, get an OpenAI API and credits. Okay. And I'll try and go along with everybody. My recommendation is you could probably, and again, it's not necessary, definitely not necessary. Uh, we can still follow through with everything and you'll learn a ton. But if you actually do want to use this, you could probably buy like $1 of credits and have enough to run this notebook dozens of times. If you pick a small model, like let's say GPT-4o mini, which is quite affordable. So just to show you guys what I mean, you'll go through this process. Unfortunately, OpenAI does quite a bit of overhead to sign up for this type of stuff. But okay, you would click that, sign up with your email. Eventually, you're going to get to your API platform dashboard. Okay, and here you should be able to see at some point you've created a project, and in that project, you've kind of picked an API you want. I think in the sign up process of the first few steps, you'd be like, oh, I want model GPT for O mini, or I want this and this and this. Um, and I think you could pre-populate it with some credits and be able to just hit the ground running. Let's see logs. I actually don't use their dashboard for APIs quite often. So honestly, even me getting back to this was a little bit frustrating. Create new secret. Perfect. I have also heard you might be able to get free credits as an initial user or as a student. Feel free to try that out. And okay, one more person asking for the link. I will send the link one more time. Share. Okay. Notebook. Yeah. So, and then someone asked a great question, which is I do have it here. You don't need to, use API credits to run agents. You can definitely use a local model. And there is a section in the notebook where we'll actually load a model locally, Qwen 3 1.7b. I think most people's even personal laptop should be able to handle this model. But the issue is, you'll need to do a lot of the wiring yourself, which is not a problem at all. And I'm actually happy to spend, 5, 10 minutes developing in this workshop, trying to get this to work. It should be pretty fun and interesting. Just note that the installation of VLLM might take you a while, but we'll get there. So TLDR, there's flexibility in the notebook. If you don't have OpenAI credits, if you do, if you want to load a local model, if you don't, just kind of throwing it all out there so everyone knows in advance what we're going to do before we start jumping into things. So with that being said, I think you get some credits when you open a new account. Yeah, cool. So see if that sign up works for everybody. If not, no worries. Let's follow along. Um, and now we're at the 25-minute mark. Oof, time flying by. Okay, let's jump into it. I really want to share this kind of graph because I think it really just gets the point across of like what the heck is an agent. Check the Q&A. Perfect. Okay. This is an agent at the simplest form. And actually, if you go by Anthropic's definition, Anthropic, maker of Claude, basically one of the best models out there. They wouldn't even call this an agent. They have a different definition for agent, which is why I always ask the question, because everyone has a different definition. They would call this a workflow. But point is, it's just an LLM with the ability to access different tools uh, to respond to some input. And when you talk to ChatGPT, actually, you'll notice maybe it'll search the web. Maybe it'll write some Python code for you. Maybe it'll write a file. All of these things are different tools that it's actually accessing under the hood to just try to solve the problem as best that it can. And then finally, at the end, you would imagine this LLM with these tools has met some condition. It's like, okay, I think I've solved the problem. Let's go respond to the user. And then you get the output, right? You might call it like these are autonomous systems that perceive their environment, they reason about it, and then finally generate a response. You could also just call it a workflow, right? You give an LLM access to these tools, you say, use this process, give me an output, done. So as I think we're all seeing, the reason this stuff matters, and I think a lot of us are data scientists, is agents are just great for automation. You can just drop a CSV and get a pretty good analysis from an LLM with access to tools, right? There's real world impacts. Kind of as a developer, one of my favorite use cases is using Cursor. I don't know if, and I'm curious, maybe by like show of hands, who has used Cursor before? This is Cursor. This is an IDE like VS Code. Uh, but I would call it puts AI and LLMs as a first class citizen. It's all centered around developing code with LLMs. So you can easily ask questions to some agent, explain this to me right there in your IDE. Now, the problem with notebooks, unfortunately, with Cursor is not very good at handling them. So for the time being, I'm just going to copy paste raw text. This is annoying.
So
Add
while people are setting up, I should just let you know that we are going to start a
oops.
6 weeks mini boot camp on AI agents, which Sammy and another of our faculty is going to give. And we will announce it soon. You just tune in. Thank you, Sam.
Cool. Awesome. And okay, I'm finally getting this to get going. Again, can just ask, what about this? Basically, LLM is your code assistant. And it actually noticed I have a security key that I had pasted in here, or one of my private keys. So I removed that. I was just keeping that in there to test the notebook. But to me as a developer, and just to give you guys context, I mean, I develop on Cursor daily, uh, work with LLMs daily. A big part of my job is actually the pre-training and post-training of LLMs for a new domain that the LLM has not been trained on, and then giving the LLM to other developers in my company so that they can become more effective. So this is kind of like my day-to-day that I'm very familiar with, and I'm also happy to like answer any questions that people might have. But with that being said, let's uh let's just jump into it. I think we get the premise. If you have the notebook ready in your end, let's install this OpenAI SDK. Okay, this, and if you go see the docs from here, OpenAI has pretty great documentation too. Once you have an endpoint, there's many different ways you might want to call it. They have a quick start guide for 5 minutes, many different models. I think the biggest thing here is being able to create a client, right? So let's import this client class. You'll have some secret key. Right now, I just have a file in my local Jupyter secret.txt that has my API key. Uh, the model I'm going to communicate with is GPT-4o Mini. This line, this will be useful for running agents down the line because it's going to check your OS environment variables for the API key. But we can simply run that, and if everything works out well, you actually have a client to talk to this OpenAI model. I'm curious, show of hands right now in the chat, has anyone been able to uh, get their own API key in this time? I see one. Yes, yes. Great. Yes, cursor is free, by the way. Perfect. If you want on your end, you can just, copy paste. You can just easily paste your agent here or paste your API key here. I don't because, I'm sharing it to everybody. So it's a quick way for me to lose a lot of money. Uh, But for you guys, that's totally fine. And down here is just, let's get a response from this model. Simple one-liner, write a one-sentence bedtime story about a unicorn. So we can run that. It should take a few seconds. And yeah, this is our response from GPT-4o Mini. If you guys are curious, GPT-4o Mini API pricing, you can get this information again from OpenAI. Down here, I think they have 4o Mini. There we go. Okay. So 60 cents for 1 million input tokens. And this, I swear this is more expensive than it used to be, but okay, $2.40 for 1 million output tokens. That 1 million is a lot. Like for your individual use case, think about what that means. That's basically rough estimate a million words uh, for input and output, and that'll cost like $2 or $3. So for your educational purposes, it should be more than enough to have like $1. And you could, again, run this notebook many, many, many times. The fun thing with agents is they consume credits like crazy, which we'll see because they do so much and it's all LLMs under the hood. But I digress. Another thing you can do with these models, and maybe it's not obvious, you use ChatGPT, uh, you're used to asking questions, blah, blah, blah. A lot of these things get abstracted from you, but these models have different modes that you can communicate in. And we'll go into kind of the underworkings of LLMs a little bit later in this workshop around here. But for example, one question that might not be obvious if you haven't worked with LLMs is how do they handle conversations? Like how does an LLM know what is happening in a conversation? And the funny thing is, it's kind of, and I'll show you in text, but it's like hard-coded strings that get passed to the LLM saying user, which is us, I might be the user, you might be the user. And then whatever the assistant, whatever the LLM responded with, and this just keeps appending and appending. And what the LLM really responds with, so basically, every time you hit an LLM, you basically say, okay, this is the current state of my conversation. Please answer and the LLM is trained to answer the user's latest question. So if I run this, it's going to see that the last thing asked is user asking, and if we multiply that by 10. Obviously, standalone, and if we multiply that by 10, makes no sense. So for example, if I comment this out of the input, it's going to say, what the heck are you talking about? Right? What do you want to multiply by 10? Because it doesn't see anything else in the conversation. All you sent to the LLM is this single query. But if I give it the context of basically a conversation that is happening where the user asked, what is 2 plus 2? The assistant responded with 2 plus 2 is 4. And then we say, and if we multiply that by 10, we should be able to get, yeah, if you multiply 4 by 10, you get 40. And as a conversation grows, this list of messages is really just what grows under the hood, under all LLMs. Also curious in the chat, show of hands, if this is like let's say, net new concept for people that, this is kind of how it's handled. One thing I could do, and, just to start popping around with this, I'm going to confuse it because there is no answer. I'm curious to see what it says. Okay, so it just tries to answer everything at the same time. And let me just quickly take a peek at the chat. Is the meeting recorded? Yes. I see someone asked, could we use Llama 2 to baseline the LLM? Not quite sure what you mean there, but happy to provide more clarification. Okay, perfect. Cool. Um, Another thing we can do is, where do I copy pip install OpenAI? Just in a notebook cell should be fine to run your code. So anywhere here, this should work. As we all see, we're kind of waiting for the response to come in one. So obviously these APIs, once you have your client, and again, this is just some class that handles a lot of the heavy lifting for us. Once we have this, we can also stream. Now, I don't like the way Colab prints out streaming, but this is going to get us one text at a time. And maybe one thing I can do just to make it obvious that I am streaming. Oh, this is still running. Yeah, this is a good way to spend too many credits. I'll make it 10 instead. You're going to see every token coming one at a time in response to this question. Yeah. So the API lets you do that. And maybe you're a developer and you want to use this somewhere down the line, or you don't want to wait for a big response. Uh, these APIs are stream native, so super easy to do stuff like that. Cool. There's many things you can do with the OpenAI client. Again, let's take a peek over at their quick start, right? You can generate texts, which is what we've looked at, right? This is what I copied, write a one sentence bedtime story about a unicorn. You can analyze images, right? If your model is multimodal, which basically all of them are at this point. Let's say you have a URL, right? They give you the format of how to paste in the input such that the model can understand an image and answer your question about it. And then, okay, they kind of give this preface of extend the model with tools. Okay, and this goes down the rabbit hole of agents, but you're giving the model the ability to interact, maybe search with the world or read a document or whatever it might be. That's kind of the meat and potatoes of agents being able to run tools, but we'll dig into that later. Again, streaming, right? Very straightforward to stream. And then, they give you a bit of a quick start on agents. Okay, so we'll be diving into a little bit of this and going into a bit more detail, but a lot of this stuff is available on their documentation. And, I'm using OpenAI right now just because I think it was pretty easy to set up. I've never used, just for context, the OpenAI agents SDK, this thing. This was the first time. I'm like, okay, let's try it out. It came out pretty recently. The reason being there's so many agent frameworks, right? And even, yeah, they'll give me a summary. You could use LangGraph, you could use LangChain, you could use AutoGen, which is a very popular one from Microsoft. There's so many. It doesn't really matter too much to start out which one you pick. Just pick one, get familiar with it. Once you learn one, you kind of learn them all. It's just different ways that agents are abstracted. Cool. I'll close a bit of these. Perfect. Any questions so far? Someone asked an interesting question. Hi, is this LLM doing reasoning, like showing the steps it is executing? So GPT-4o mini, the model I have, is not like natively reasoning. But if you mean, can we show the chain of thought of the LLM using tools? Yes, we'll be able to do that. And one thing, by the way, let's say we do this. I could add one more input. It's not exactly reasoning, but it lets the model always show your chain of thought before answering a question. So I'm basically encouraging the model before you give any answer, kind of think first, really be deliberate. And this has actually been shown in research, and it's known to improve the answers of LLMs. Give them a chance to kind of reason first before spitting out an answer. Okay. So, and it's giving this in Markdown, so that's why you see a little bit of funny formatting, but it's trying to reason a bit more. Always provide, and I can be a bit more verbose here, a thorough. Now, this question is very simple, so yeah, there's not really much chain of thought to be doing, but I digress. So that's hopefully helpful to let people poke around with the API. Just chat with a model in your notebook, kind of feel it. It's always very fun and magical. Very cool. Then let's go one level higher, right? Let's actually start building a simple agent with OpenAI and their SDK. So there's a few different levels we're going to cover here. Maybe level one that we'll start out with is just a basic agent that will enhance with the tool, right? We can start with a haiku generator, and then we'll add layers from there. One thing I mentioned is there's so many great agent libraries out there. We're using OpenAI because it's simple, it's convenient. We'll stay in the OpenAI ecosystem just for the sake of this notebook. And yeah, they actually have great docs in addition to what I showed you guys to do so many different things. Like this whole thing, you could probably go through all of this and solve almost any agent use case you have, right? Quick start, examples, running agents, streaming, context management, voice agents, so on and so on and so on. And what you should do, to be really like an AI native person is you don't need to read through all of this. Use LLMs to help you out here. Give me a voice assistant agent implementation in Python. Right. And let the LLMs do a lot of the work for you. The great thing is once something is very well documented, it's very easy for other LLMs and other agents to make use of it. So I'm not going to run this, but hopefully this should help everyone get started quickly. I think needing to write and read all this code by hand is not the state of just developing and AI. So hopefully it helps people just get started. I know there was that comment in the beginning like, oh, I'm hitting bugs. Hopefully that'll help resolve bugs. Cool. So let's get started with our agents in our notebook. We can pip install the OpenAI agents SDK. This should just take a few seconds. If it takes longer, let me know. Cool. And after we do some pip installing, we're just going to import these libraries, right? They have a very simple agent class, right? Where it really just handles all of the like messy scaffolding, which we're going to dig into. But let's for now just abstract it all away. Be like, okay, there's a magic agent class and it's going to do everything I want. Cool. OpenAI has made that for you. There's also a runner kind of helper class because there's different ways to just run an agent. It's fine, it just helps you run it. And again, if you are running this, make sure you have your OS environment variable set because the agent class is implicitly going to try to read this so it can work. Okay. And one simple thing we can do is let's make a haiku poet with the instructions, you are a helpful assistant that writes haikus about programming topics. And that's it. I'm simply going to write this. The thing with runner, and this goes more into development and execution, but you can run things synchronously, asynchronously, multi-threaded. So the runner also abstracts away a lot of these things for you. Like if I wanted to run synchronously, I could, but in Jupyter, this is going to cause problems for reasons we don't need to get into. I think they have a run async too, but might be wrong. I think by default, run is async. They even have a streamed. So I've actually never tried this. Curious what happens. Ah, yeah, I can't use a wait. Okay, so let's do this. Okay. And I'm sure there's some way to like stream this result object. Uh, and again, just to show you guys the beauty of being able to develop fast. Now, if I were in Cursor, I wouldn't have to switch between Notebook to LLM Assistant, but I am, so there's fine. Okay, how can I show the streamed output? Sure. So just gonna try it out. Again, don't want to spend too much time on it, but I'm curious what is happening here. Yeah, this is it. Da, 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 da. OpenAI.agents import. It's a bit of a hallucination here. I don't need this. Split the keyword, event handler. Yeah, this is the fun part. Okay, so I would want to dig into this, but honestly, not the point of this workshop. Uh, Going back and forth and going through the docs, hopefully it's a solvable problem, but did just want to share that with everybody. Let's take a pause here. Who has been able to run this so far? Has anyone been able to actually get their agent up and running, be able to do any interactions with an LLM? Okay, I see a few people. Awesome. And I'll maybe paste one more time. Yeah, some people are joining late. That's totally fine. I will share the notebook. And there is a recording, I think both on YouTube and on LinkedIn. So I know, yes, if you don't have the credits, that's totally fine. Feel free to just download it, run it later, try it on your own, and it should just give you a bunch of scaffolding to try out a bunch of useful things. So up until now, we haven't really done anything crazy, right? It's just how is this different from an LLM? Why the heck do I need this agent abstraction? Can't I just ask a regular LLM this question and get a similar output? And the answer is, yeah, that's totally correct. Uh, which is why we'll go to the next part, which is actually adding some tools to your LLM. So this is where it gets interesting. And every agent library kind of has a similar but slightly different way of doing this. The whole point is just to give callable objects to your LLM. So one thing I might do is, and actually this comes straight from the library, I will give my LLM the ability to search the web by importing this class from agents, web search tool. And I'm also going to define another tool, which is just a Python function to multiply numbers that I provide in a list and then return that output. So that's what I have here. Then the agents SDK, what it lets you do, and the kind of the core concept, if we go back to that image, and I really like Anthropic's depictions here. You can hook up an arbitrary number of tools to the LLM. Right now, what I'm doing is just giving it two. Okay, I'm going to give you access to web search, and I'm going to give you access to be able to multiply numbers because LLMs don't natively know how to multiply numbers, right? But instead, just like us, maybe I can use another tool, use a function to do this for me. All right, so I have this search agent class now. right? And we can see just a bunch of the scaffolding going on under the hood in this class. Name calculator agent, we've given it some instructions. Um, we have some settings for it, and we have some tools that it can use. And again, just so you guys see it very clearly, this is just some class from OpenAI to do web search. This is just some function that I've added this decorator at function tool that is unique to OpenAI, just to kind of make it easy to pass to the LLM that, hey, this is a function tool for you, but this is just a function tool. There you go. We can delete this. And this will become hopefully, I think, a little bit clearer in the next couple of sections. But let's kind of iterate through the tools that the LLM has access to. So maybe before I go forward anymore, I mean, is this concept of like tools and LLMs making sense to people? Uh, is there any questions on like why do we do this? I don't really understand why this makes sense. Or is it relatively clear? Beautiful. And I'll take a pause here. So for secrets.txt, you can put it anywhere in your developer environment. Just if wherever, let's say your notebook lives, if you want to put it there, that's fine, just so you can read it. But as long as you know the path to this file, you can pass that up to the cell in the beginning of the notebook and read it from there. Okay, I see a good question. How does it know that the function multiplies numbers? Perfect. So this is where we get into the schema of a tool. And this is actually this is how the LLM sees your tool. It sees it as a JSON. And there's a few interesting properties here. Uh, Part of it, and actually I don't really love how OpenAI is showing it, but I'll show you guys in the later sections. Tool.name, tool.json, parameters, json.dumps. What if I just do this? JSON.dumps. Yeah, that's what I thought. What if I just print it? Okay, for all intents and purposes, this is what the LLM sees. It sees, hey, I have some function tool that is actually in JSON format. It has name, calculate multiple number, or calculator multiply numbers, no description. But this is actually super helpful. You want to give a description to the LLM of what this uh, tool does. So maybe if I'm a good developer, yeah, I'll include some doc strings. And the nice thing with the OpenAI system is I think they automatically detect this as the description. So if I run this again, dang, they don't. That's unfortunate. Then there must be another way to do this, but for now, it's not too important. Point is, you're telling the LLM the name of your function, you're giving it a description, and you're telling it exactly what arguments it takes. So it takes an argument numbers, which is going to be a list of floats. Right? And they have some things here, but it's a list of floats. It's required, right? So it knows if I use this, I have to give this argument. And I'm also saying somewhere down here is that it returns a number. So this is giving the LLM just as a string, basically, context of what my function does and how you call it. So we can test this by running this nice, interesting example. We can use the runner.run object, and we can say run the search agent for the question, what is the current president's age times two? So this is going to take two steps, right? First, Current president. I mean, the LLM is going to have to search who that is. Um, Once LLMs are trained, their knowledge is kind of frozen. So if it wants the most up-to-date information, it has to search the internet and see what's out there. That's step one. At least that's what we would expect. Search the internet and find the current president. Then two, okay, let's multiply whatever that number is by another number. And hopefully the LLM decides, okay, for multiplication, I have a tool that does this for me. And we will get back the response Donald Trump, so I picked out who the president is 78 years old, and his age times two is 156. Now, you might think, okay, well, an LLM could probably do this without tools, right? Like, why do I need tools? It's a fair comment. The answer to that is, this is a relatively simple example. But for example, if I needed to search something that the LLM was not already confident on, it's probably confident and it's seen a lot who the current president is. But who knows? Maybe his birthday was yesterday and the LLM itself would get the wrong number because it's not trained as of information yesterday. And then similarly, okay, times two, LLMs can kind of do that simple multiplication. But what if I wanted to make it, a little bit more complicated, right? Give it really complex multiplications. There's no way the LLM can do this under the hood. It should use the calculator tool to figure this out. Cool. One thing that we'll dig into is actually let's dig into what happened. Under the hood of these agents is actually, you can think of it as the LLM having a monologue with itself. It starts, the monologue is initiated with the user's question, whatever you ask. And then this is the beauty of agents acting autonomously. The LLM itself will decide, okay, what do I need to do to answer this question? I know this is the inputs I have. I have the user's question, and I also have these two tools, right? We kind of give this information as input to the LLM. I have these two tools. Well, maybe the first thing I should do is call web search, which is what we're seeing in the kind of dump of the results. And we're actually seeing the LLM decided to call web search to find out who the president is. And it's a little bit messy in the JSON, but you're going to see that the response of the tool was as of today, June 1st, 2025, the current president US president is Donald Trump, who was born on June 14th. So actually, in 2 weeks, if we run this again, we're going to get a different answer. And if we don't use the search tool, we might be wrong because his birthday is coming up. Another thing we should see, and again, just to kind of skip through this, is step one. Okay, I know the president's age. What do I need to do now? Well, I need to multiply that by some numbers. Oh, I have a tool for that. Perfect. Let's do it. So we actually see that the LLM is trying to call the call multiply numbers function, right? Function call with the arguments 78, which is his age, 2.252, and 3, blah, 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 blah. So it's using our function. It's like, hey, run this for this input. It is completed, and we get an output. 587.622, blah, 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 blah. And then finally, at the end, it synthesizes this information to be able to give the final response to the user, which is this, right? And that's our final answer. So that's kind of dissecting what's happening under the hood of a, agent with tools. Questions so far? Anyone? And I see a question to or make this bigger. Totally reasonable. I'll zoom in. Uh, I definitely tend to see small fonts too much. We're at the 1 hour mark. So let me just get a vibe check, right? We have about an hour to go. I think there will be some collaborative examples coming up. Feel free to ask questions. I'll take a little bit of a pause now just to make sure I'm addressing some questions. There's a lot, so I might not be able to get to all of them, but I will try my best. Good question. Okay, so one person asked, how deterministically do LLMs call tools once equipped with them? That is a very good question, and there's actually different ways you can control this. OpenAI actually themselves, if you go to their documentation, I'll just pop this down here, tools. I did remember I read this. They should have it. Maybe it's in their other tools, using tools. Dang, that's frustrating. Let's try this function calling. Okay, I won't spend too much time going through their documents, but I think there's two answers to that question. One, how deterministically? I think LLMs in general are determinism kind of goes out the window. You can even try these tricks like to set temperature to zero and whatnot, right? Temperature just kind of varies, which or kind of controls which token might be picked next when you generate from the LLM. No matter what, you'll get some indeterminism there, I think due to numerical stability. But then there's a whole other one, which is there's kind of a known thing where as you add more tools to an LLM, like I gave it two, if I gave it 200, something tends to degrade, right? It doesn't really know which tool to use, and it might just only end up effectively using 5 or 10 of these. In general, the recommendation right now is probably don't give an LLM more than 10 tools. If you do need more than 10 tools, that's where we get into multi-agent examples, which we're going to jump into next. So it's kind of the idea of instead of giving one LLM with a lot of tools to do a lot of different things, what if we create multiple LLM with tool agents that can interact with each other? Maybe you have a researcher, maybe you have a coder, maybe you have a project manager, and you get them to interact with each other. The other thing too is via the API, and I'll try to show this. I'll quickly flash it here. Okay. When you call tools via the API, you can actually specify the LLM's tool choice. So you can let it be auto, which basically you're letting the LLM decide when it wants to use tools, or you could have it be like forced, right? This is a parameter you could say you must always use tools. And that's up to me to the developer to provide. Maybe it's something I want for my workflow. Hopefully it answers that question, but it's definitely a very relevant and good question. I think another one is why does it assume it's the US presidents? Good question. It could definitely be I'm in a different country and maybe I'm in Albania and I meant that. So it's kind of making an assumption for me. Um, One thing that actually ChatGPT does to avoid this, you don't ever see it when you use it, but every time you ask a question, tell me my own metadata, like location, that is pasted into our conversation. There's actually metadata that gets pasted. Yeah, exactly. So to make sure that the LLMs know as much about you as possible, all this metadata gets injected into the question, where you're coming from. So it knows I'm from the US, uh, time zone, the current date right now, all of these things. Some of these are, I think, hallucinated, but it does get passed in. So it's just make sure it can give you the best answer possible. To have the affinity to the given function. So is there a way to define for the LLM to have the affinity to a given function if multiple functions in the same task are available to an LLM? Let's see if I understand that. Doing the same tasks are available to an LLM. Durga, I'm not sure I understand that, but one problem is if you do have tools doing the same thing, yes, the LLM will kind of arbitrarily pick or maybe not use them as intended. So you really want to make sure your tools are mutually exclusive as much as possible. How does system know when to use tools rather than LLM? So actually the thing is there's the LLM is the system. Under the hood, and we'll see it in the example where we go here, it's the LLM doing all the decision making. The LLM, let me give you a bit of a workflow. User, and maybe I'll write it here. This is what the LLM sees, and it all goes in a conversation. Why am I not writing? User, blah, 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 blah. Okay. LLM sees this and it goes, I want to use, and it'll give some basically use tool A. And then basically what we do next is actually execute tool A under the hood, give its output to the LLM. So now the LLM sees the user question and the output of the tool, tool A, blah, 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 blah. Now again, LLM sees this is, can I answer the question? That's ultimately its goal. Maybe no. So then it says, okay, no, we need to use tool B. And this is all just the LLM itself deciding what it thinks is most reasonable. Now, of course, this is super potentially error prone. Maybe it makes the wrong decision. This is why agent systems are very, and if you guys are data scientists and familiar with all the modeling, they're like ultra high variance systems. Especially as you add more tools and you add more complexity, the variance skyrockets, and it's very hard to know what the LLM might do. So anyway, you might do the same process, and then eventually, LLM basically decides, okay, I have enough info to answer. Answer is blah, blah, blah. Hopefully that makes it a bit more clear. Peek at the chat again. Okay, I think we're good to keep going. Hopefully, again, just kind of flashing these concepts to everybody. This is where LLMs really get, or agents really get interesting. It's where you have multi-agent collaboration. So let's say instead of just one of these agents, what if you had multiple of them, each with access to their own set of tools, be able to interact with each other? That's where you can start doing very interesting and complex tasks. And the nice thing with, and I'll just zoom out so this image is kind of in context. The nice thing with these agent frameworks is they kind of give you these out of the box. They kind of make it easy to get LLM agents to interact with each other. Alternatively, you could do it all from scratch, which is totally fine. Maybe it would be like a advanced notebook implementation. But for now, let's just use what OpenAI has. For example, we'll go through a routing pattern where you have, let's say, a triage agent that determines the topic and routes the question to a specialized agent, right? So let's say maybe you ask me a question and I don't know the answer, but I know on my team I have a Spanish agent, a coding agent, and a architect agent. I'm like, oh, you just asked me an architect question. I'm going to throw the question to my architect expert to answer that. So we're trying to mimic these like human workflows, but through LLMs and through tools and through agents. Similarly, you could have a manager pattern. So a manager agent breaks down a complex question into subtasks, which we're seeing here, delegates them to sub agents, and then aggregates the result. This one is very common, right? Especially as a task gets more complicated. Let's say in GPT deep research, I suspect they use something like a manager implementation, where let's say you get a very or very ambiguous or multi-step problem. You need to break it down into the steps that are required to solve this problem. Maybe we need to do A, B, C, D. I will hand off task A, B, C, D to my respective sub agents, wait for them to finish answering them, aggregate them, and then make a decision. Do I have enough information to answer the user's question, or do I need to keep spinning up subtasks and keep using my sub agents until I do? So that is very, very powerful, and you see that implementation or that workflow kind of depicted here. Again, a bit of a more trivial example, translate hello to Spanish, French, and Italian for me. Like an LLM could just do this itself. But one example maybe could be, hey, here's a link to a Jira ticket describing some issue. Please create the pull request, to solve this issue in code. And that's where we're at with a lot of LLMs these days. If you guys have heard of like OpenAI Codex, that's basically what they do. Let's go step by step. What does it mean to read a Jira ticket and then create a PR? You need to actually read the contents of it. You need to understand them, maybe do some extra research. Maybe you need to find more context about the problem and then break it down. Okay, this is a coding problem. I need to do A, B, C, D. Let's implement that. Then let's implement tests to make sure A, B, C, D is doing what we expect. And then let's author the PR. So we can kind of keep going down that route. But again, very powerful. Just in the interest of time, I do want to give you guys a bit of a demonstration of the first one, which is triage agents. In this case, it's going to receive a user question and forward it either to a math tutor agent that we've created or a history tutor. Again, just a trivial example, but hopefully it gets the point across for everybody. OpenAI actually lets you implicitly create this agent structure by giving you the ability to instantiate the agent with handoffs, right? And even if you hover over the documentation, these are sub agents that the main agent can delegate to, right? You provide a list of handoffs and the agent can choose to delegate to them if relevant. Now, this can keep growing in complexity because I'm sure I could create a sub agent that also can have handoffs to other sub agents. So you start getting agents talking to agents, talking to agents. And this is very common. You kind of have like group chats of these agents working towards a task. For the response, it did come through. The question was, who was the emperor of Rome during the eruption of Mount Vesuvius? I have no idea, but I think, and if we go through the input list, we get some answer. I don't really care who it is. Um, Titus. Cool. We see that what the LLM, the main LLM decided to do, the triage agent was like, okay, this is a history question. And we gave it these instructions. This is a history question. Let's go hand this off to the history tutor. The history tutor gets that question, responds with a text, like, okay, that's sufficient to answer the user's question. Boom, let's finish. And there's good questions here. Um, what if the manager can do everything? Yeah, sometimes that happens. So kind of as developers, the trick with agents is you can make them as complex as you want, but the fundamental question is like more complexity is not good. Only add complexity, and this is kind of the bane of agents. You can make them ultra complex, but is it actually good for them to be this complex? What if a single LLM can just do this? And that's why the best advice is just start simple, literally just LLM. Can it answer and solve my use case? That's what we find in the field. If it can, great. If not, and by the way, we could go through, there's some really great guides that even like OpenAI and Anthropic author, Agent Design Foundations. I'll just quickly parse through this. Can an LLM solve it? Maybe yes, maybe no. Okay, what about just a single LLM with tools, which is kind of your bread and butter? Can that solve my use case that I'm trying to solve? If yes, great. Forget about these multi-agents. But maybe it can't. And then in which case I need to do multi-agent orchestrations, right? I'll just quickly flash this here. This is a good, coming straight from OpenAI's mouth, right? Maximize a single agent's capabilities first, right? More agents can provide intuitive separation of concerns, but yes, complexity, overhead, cost. Again, APIs are not free. So you imagine all these LLMs talking to each other. Somebody has to pay for that. Uh, and what you often find in production agent systems is complexity becomes a nightmare to handle. Imagine an agent composed of 10 sub-agents does something wrong. You have to dig through basically the logs of every single one of those interactions and figure out like what the heck went wrong, which is a nightmare. And it's also, again, high variance. Maybe I ask the same question 10 times and I get 10 different responses. Is that really what I want for my problem? Maybe yes, maybe no. So these are just things that are like very relevant to, AI engineers, developers. Yeah, one is more complexity ever good. Yeah, that's the regularization, right? Always regularization. Does the extra complexity justify itself, right? Does it actually improve performance enough to justify the complexity? If it does, fine, use it. If not, scrap it. And I see someone, are multi-agents like MCP servers? Okay, so we have a section on MCP. Let's just jump into it. Because now we're getting into like really the meat and the fun potatoes of LLMs. Um, First, let me just flash this manager agent. Okay, let's pretend we have this scenario. It receives a user question and breaks it down into subtasks for specialized agents to tackle. This is probably like a super naive implementation of like the deep research. Yeah, run deep research if I wanted to. As you guys, if you've used this tool, it can run for half an hour, researching and solving your problem. Under the hood, it's for sure some agent or multi-agent orchestration, doing researching and synthesizing and all of this stuff. Here we have a simple one. We create a manager agent. You're a project manager. When given a complex question, break it down into subtasks. Now, if the question is not complex, maybe the manager itself can just respond. The manager doesn't have to use its tools. This is kind of the flexibility you want when you author these things. But yes, you can choose to summarize, research, get definitions, whatever it might be. Okay. I'll ask a question of like explain the role of the Treaty of Versailles in causing World War II. This thing will run. One thing you also can do in agents is if you really abstract it to high level, it's like an LLM in a loop. That loop, you don't want it to go infinitely, right? What if the question is very hard and the LLM keeps trying to use different tools? Typically, what you can do is set like a stop criteria to make sure the agent just doesn't spin indefinitely. This can either be a text that the agent sees, or it can be a maximum number of iterations. So you can think of this is literally an iteration. Input, agent makes a decision, decision returns an output back to the agent. What do I do? Right? How many times do you want to allow the LLM to do that? Okay, we see some response. Okay, interesting history context, but this is an example of again what the agent was doing, and we can see, let's see. Okay, it transferred to the definition agent. Now there actually is a way. This is kind of abstract, and I'll show you guys in the next section. There actually is a way to find out exactly what the manager agent said to the, let's say in this case, the definition agent. In this way, I found it doesn't really tell you that. It just tells you that it used it. It doesn't tell you how it used it, but we'll dig into that later. For now, let's just take it for granted. Okay, LLM decided to go to a definition agent. Maybe it was like, what the heck is Treaty of Versailles? I don't know. Then it's like, okay, let's research about this. Actually tried to do multiple handoffs. And then actually tried to do definition again. before finally giving a final answer. So interesting. Uh, if I change my prompt and I change my agents, I might get a completely different output, but this is how we can take a look at what's happening under the hood. Yeah, why build agents if you have Manus, for example? Yeah, so Manus is an agent, right? So you don't need to build one yourself, but let's say you do, or let's say you work at a company that does. I mean, this is what's happening under the hood. All these kind of decisions and trade-offs are being analyzed to create something like Manus, which is just to give everyone, yeah, Manus AI, some context here. Well, I'm not going to use it, but it does the same type of thing, right? It's an LLM or maybe even multi-LLM system with access to tools. So if that is something you're interested in, or if you're just curious in seeing what happens under the hood, this is it. And speaking of going under the hood, I think, okay, we have about half an hour left. I think we're doing good on time. This might be a bit of a fire hose, might not be. Apologize for that, but there's a lot of interesting things to cover with agents. Uh, Under the hood, let's go dig into, forget this agents abstraction. Let's do it ourselves using just the OpenAI API. Okay, let's write a couple of tools ourselves, and let's write a little class that we're going to call mini agent, just to kind of handle the scaffolding so we don't have to worry about it too much. And again, the tools are just Python callables, right? Let's say you want your agent to be able to actually write to your file system. You would give it a tool to do that. And the tool is just a function that writes to file system. Like we can play around with this right now. And so on and so on. Let's start with a really simple example where I just have two tools, add and multiply. And I see them here. I'm actually just creating a dictionary. This is very common, but what is this dictionary? It's the key is just the string name of the function, and then the value is the actual callable function. So for example, just to show you guys what I mean, if I want to use this to add numbers, right? This is a reference to the function. Um, I could do 3 and 5, and I'll get 8. This might be a weird way to see how tools can be executed and functions can be executed, but very, very useful. Okay, this is where we get to the schemas. This is fun. Let's just print one of these guys. Okay. This is how the LLM will see the tool. The LLM will receive this along with the user's input, a user's question as input. So the LLM sees, okay, I have a function called add, whose name is add, that has a description, return a plus b, and it has the following parameters. It has an argument a, which is a number, and it has an argument b, which is a number. Right? And this is just coming straight from the definitions here. And they're both required. Okay. Now, with this information, this is sufficient for an LLM to see this and say, okay, I understand what this tool does and how to call it and what it might give me back. So I'll kind of keep that in mind as I try to solve these problems. Under the hood here, there's just a class abstraction to kind of handle doing this ourselves. I'm not going to go into detail, but I think this is the key elements, right? Really how this class is going to work, and I'll just show you guys an example of it working right now. I didn't run it. Cool. And I'm actually going to do this. Do not use Markdown in responses, plain text only. I don't want to see Markdown. Let's try it again. Cool. So this is really digging into the guts of the agent. Um, we've removed that agent abstraction, and hopefully it makes it clear now what's actually happening under the hood. We just have a client which we created before, right? Some way to hit an OpenAI endpoint, just a model name. It's just needed, GPT-4o mini. We have tools. We have the tool schema, right? So the actual JSONs. And then LLMs, again, we're going to operate in this conversational way, basically a list of dictionaries indicating what is happening in a conversation. All we do in this ask function is specify two things. What I'm asking, right? What the user is asking, which is query, and then max iterations, which is you're going to see this whole LLM in a loop concept. It's literally just LLM in while loops or for loops. Let's go step by step. Step one, and give the LLM this question, right? Which is the instructions I gave it and whatever query I've asked. Let's give it the information of the tools that it has available to it, right? So this is the schema. It's this. We're literally giving the LLM this. It's like basically imagine it just being pasted on top of the user question. And we're saying, okay, use tools as you see fit, auto. We get a response from the LLM. And basically in that response, this is kind of the dynamics of how the API works, but it'll say if it wants to use a tool call. And what we're actually doing is, uh, let's see, that tool call is the JSON. We parse it and we actually run the tool. That might not be clear here, but we're actually running the tool it's deciding to call right here in our notebook. And we keep doing this until eventually uh, it's no longer a tool call, which implies the LLM has decided to respond. So we can see that here, step 0. It's decided to use tool add with arguments 2 and 2, and it gets a response of 4. Maybe let's make this very clear. Step 0, tool called, tool executed. Okay, so we're seeing, all right, I have a tool called to add A and B, and the execution result is 4. And we give that back to the LLM. Uh, then it wants to multiply. So it wants to do 4 times 10, because that's basically the question asked. Okay, that tool gets executed, that function gets executed, we get 40, and we give that back to, all of this keeps getting fed back to the LLM. Then it wants to do, wait, what does it want to do? Add 4 plus 7. Um, Interesting. 11. Then multiply the result by 10 and add 7. I actually don't know. This looks like a weird bug. Um, they're both in step 1, so let's see here. Okay. So the LLM can decide to use multiple tools at once. In this case, for whatever reason, I'm not clear on the LLM just doing weird things. It's decided to use 2 tools at once. Um, Both of them actually get fed to it, but then finally it synthesizes the response. Great. If you actually want to see what is happening under the hood, this agent class kind of has all our metadata. This agent instance, we have messages. If you're familiar with like LLM messages frameworks, this is the ongoing conversation happening to the LLM. So it starts with a system, which is kind of like your high level instructions. It's your system message. You're a calculator assistant, blah, blah, blah. Then you have the user message. Okay, first add 2 and 2. Okay, then you have the agent response, or sorry, the LLM response, which is saying, hey, I want to do tool calls, right? And this is what I called. And then this is how we actually tell the LLM Okay, the tool that you just called responds with four. It gives content four. And then we go back to the LLM assistant and it actually decides, and you'll see it here, for whatever reason that I cannot explain, this is just LLM decision making, it decides to use two tool calls. Okay, we append the result of both of them back to the LLM, and then finally the LLM decides to respond with the final answer, right? 2 is plus 2 is 4. When you multiply that by 10, you get 40. When you add that, this hallucinated a little bit. When you add 7 to 4, you get 11. Or maybe not hallucinated, but it thought I wanted four. Uh, what was that? What was the question? It thought I wanted four and then two separate things. Multiply it by 10, and then another separate thing, 4 plus 7. So maybe I can change that. Multiply the result by 10 and then add 7 to that number. So I'm telling it to go sequentially. And this time we should see a different tool execution. Yes. So this time we went to two steps. 2 plus 2, we got a response. 4 times 10, we got a response. This actually is hallucinated. And then we got 40 plus 7 as a separate response. And the nice thing here is we can actually keep going to chat with this agent class. So this agent is stateful. I can actually ask it one more thing, or I can keep going. And now divide that by 2. Actually, we don't have divide, so I'll just say multiply. Okay. And it should keep going. So it took literally where we left off, 47, multiplied it by 2. Okay, now we get 94. So long story short, I hope this is kind of just a demonstration of how to build that agent interface that OpenAI gives you, how to build it yourself from scratch, and what is really happening under the hood. It's definitely going into a bit of the technical details. Maybe you're familiar with that, maybe not, no worries. But it's totally something on your end you can play around with, paste, really go crazy with. I really prefer this because it's not that much code if you really think about it. And it gives me full control and ability to understand what the heck my LLM is doing. For example, to see that for whatever reason, my LLM has decided to call in one of the steps, in here, step one, to do two separate additions. I have no idea why, but it decided it. Maybe I can look into that and be like, okay, I need to give better instructions. This is a weird behavior, and tinker with your agent from there. So I see there's a lot of chats. Let me kind of catch up with these here. Okay. Da, 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 da. If you're following along executing the token, you can check your token usage. Yes, actually, let's see. I'm curious how much I've used in this workshop so far. Say $1. Okay. Uh, I hope I don't have a $120 budget. I only funded this with a few dollars. This should be fine. Interesting. For whatever reason, oh, I'm on the wrong project. That's why. There we go. Okay, cool. So I have spent today and yesterday preparing this a grand total of 21 cents. I think I can live with that. So it just goes to show these small models, you can use them and unless you're going crazy, you won't rack up that many costs. Cool. And let me just keep catching up. See a lot of interesting discussion in the chat. So again, I know I'm giving kind of trivial examples. The number one thing you guys will see here is like, yes, you don't need an agent for the things I'm asking. An LLM itself could probably do it, but uh, I just want to start simple and show you guys like trivial examples and let you yourself come up with more interesting ways to do these things, right? I'd like to just give the scaffolding super, super simple and then go crazy with adding as many tools as you want to solve whatever problem you want. Cool. Seeing some really great discussion. That's awesome. And I'll quickly just take a peek at the Q&A as well. Yeah, does Anthropic, I'm pretty sure has an agent SDK too, but don't quote me on that. How do you keep hallucinations out? That's a great one. Yeah, hallucination is a very big topic. It's like, what is a hallucination, right? It's an LLM responding confidently with the wrong information. One easy way to do that is, well, not easy way, but one way that kind of constrains the freedom of an LLM at the cost of traceability is you do, gosh, what is it? Basically, like annotations. Basically, make sure your LLM only gives answers that are backed by some documentation. For some reason, the word is slipping me today, but you can do RAG, right? Retrieve documents as you generate, which is kind of just like a workflow. And then as you answer, every part of the answer of the LLM must be traceable, attribution, must be attributable to some ground truth source documentation. That's one way to at least minimize hallucinations or at least ensure answers and responses are coming directly from some source document. But then the problem is, maybe you want something that isn't in your source documents, then your LLM has to kind of synthesize that on its own. You want to give it that freedom, but it might hallucinate. So trade-off there as well. Cool. So hopefully that gives an idea of building a very simple, like, agent use case on your own with your own tools, with your own class. One thing you could do here is maybe like read PDF. Actually, yeah, I'll add that later. But yeah, let's say you had a CSV and you wanted it to analyze the CSV. It could do that there. For the people who do not have OpenAI credits or OpenAI endpoints, you can do this again equivalently just loading your own model. The only thing you need, and actually you probably don't even need 12 gigabytes of GPU RAM. You could probably handle 6 with the model I'm using. There's some really nice and strong, very small LLMs that are coming out. Only 1.7 billion parameters. So this will only take up like 3.4 gigabytes of RAM, add some overhead for activations. Just call it like 4 or 5 gigabytes of RAM to run this model locally on your machine. I think most people have that. It might not be super fast, depending on if you have a GPU or not, but you can try it. The only issue with this, not issue, but if you don't have VLLM installed, it's a bit of a beefy installation. So just keep in mind that this might go for a while. But once you have it, you will be able to just chat with it just like you do an endpoint. Basically, the only thing you need to do from the work we have so far is replace this and maybe replace this with a call to your local LLM instead. Basically, everything else should work the same. So it should be super straightforward. I'm actually going to try it now. I wasn't able to get it going before just because it was taking so long, but we can try that out. While that loads, another thing we can do is try to do like advanced agent use cases. So I had not run this. I have no idea if it's going to run, but I wanted to create an agent. This time going back to, the agents SDK. I wanted to create an agent to do some EDA for me. So let's say you have, and everyone's used to ChatGPT doing this. This is how they do it. You're given a file path, go do some EDA. That an LLM cannot do on its own. You need to give the LLM tools. It needs to be able to read a CSV file, for example, or read a file in general, right? Which we're giving it a tool to do so. Maybe if you want to save figures, be able to do that. And then if this is actually super trivial, I mean, maybe there's more interesting explorations I could do, but this would be a start. And then I can have an LLM that, hey, here's the CSV, do something interesting for me. I'm still executing, like I said, the VLLM runtime, but this would be one fun, more advanced implementation of agents and LLMs. And I see, yeah, a lot of very good answers in the chat. Yeah, hallucination, I mean, again, we can go very deep into that. I think one point with LLMs is they have difficulty expressing, or at least the way they're trained right now, they have difficulty expressing their uncertainty, right? The thing we kind of understand from humans is, I'm chatting with you. Maybe what I'm doing is retrieving some fuzzy memory and facts. And I seem to have a strength of how well I remember that or how well I believe that. And I'll express that confidence to you when I respond. Like, oh, no, no, I know for sure 2 times 2 is 4. But if you ask me, again, when was the Treaty of Versailles signed? Somehow, I'm retrieving into my neurons that information and it's a bit fuzzy. I don't feel very confident in it. Is it 1918, 1919? It's definitely not 2000 and something. But I'll tell you, okay, I'm not sure, but I think it's this. And at least my ability to explain uh, my lack of confidence kind of gives you an idea. It's like, okay, I shouldn't take this as 100% granted. Another thing that the LLMs will typically do is just completely make things up that are not true. You can see it in code all the time, but it'll say so very confidently, which is an annoying user experience. You've just made up a keyword that doesn't exist, but you've said it very confidently and attached it in a whole workflow. Um, Interesting problem. I think Anthropic is, they have a lot of interesting work in digging into the actual activations and attention mechanisms of an LLM to kind of understand its reasoning and try to surface that. So there's definitely work being done in this field. Anyway, I digress. Buying time for VLLM to install. Great, so it finally installed. Hopefully pip dependency resolver did not fail. I'm just gonna pretend it did or pretend it didn't. Let's see if I can load my LLM. And then this is going maybe one level, we'll go one level deeper into how LLMs work. Right now, and again, depending on if I see there's some people who are advanced, some people who are more beginner, totally fine. How the heck does the LLM work is another question. I had another workshop on that before. Do I really need to? Device string must not be empty, but usually you can just make this. Again, I always forget this. I'm going to try and get some help here because this is how we lazily develop in 2025. Let's see. But was this not exactly what I did? Yeah, so it's confused about my GPU. Uh, Let me see. Get available GPUs. I'm actually curious if this is going to run. Nah, I didn't think so. No NVIDIA SMI, unfortunately. Okay, it's fine. I kind of wanted that as just like an addition, but there's going to be some debugging. I don't want to spend the last 15 minutes debugging. Typically, this works. It's complaining something about it doesn't understand the GPU devices I have available. If anyone has a quick debug on this, I'll take it. Excuse me. Typically, so annoying. What if I just put it on CPU? Device string must not be empty. Self-dot device. Ah, not pass device. Ah, okay, I'm blind. Hmm. I don't want to import Torch because God knows what dependency hell I might go into. So for all intents and purposes, let's just skip this for now. Because I do want to try these advanced chat use cases just to, excuse me, end things off on. So here we have an LLM with that I authored to try to get me to no module agent.tools. Why do I even need that? Hallucination. Okay, cool. So I have some EDA agent. Let's just verify. Okay, it looks good. It's populated. It's instantiated. Okay, I have some data that I have prepared here, which let's just put that here. This is Google versus ChatGPT usage. I'm very curious to see what is going to happen. Okay, this is not going to run. I need to await. The goal should be it produces an image of whatever EDA it decides is relevant. And I have no idea what it's going to pick. So this is the fun of agents. Let's see what happens. Okay, perfect. So it actually did execute. And this is the report it gave me, right? Actually, I can paste this into Markdown because it's actually giving me a Markdown response. So let's do it justice. Cool. No missing values. Okay, there's key insights per column. Okay, so there's Google searches in millions. Observes a slight declining trend over time with no outliers. There we go. There's like ChatGPT queries, rapidly increasing trends starting from November 2022, right? When ChatGPT came out. Looking at other informations, correlations. Okay, interesting. It actually, wow, it made a lot of plots. Let's take a look at what this agent did. It might just also be empty. Who knows? I don't know if this is intentionally empty or if this is some bug in the agent or in my system, but it definitely tried. Interesting. Time series plot. Why did you not be able to plot things? So this is where I could dig into the agent, step-by-step reasoning and figure out what's going on. Finish with markdown, decide on a call get schema. Interesting. Oh, of course. I mean, this is not, this doesn't do anything. Um, cool. And again, to make agents, you should actually use other agents. Help me augment the tools to actually create meaningful meaningful plots from the CSV data, not just a dummy save of an empty image. Okay, you could try to craft that yourself, but also I'm confident I'll get a reasonable update uh, just copying whatever's here. Let's try it. We'll go for it again. And let's see what ChatGPT does for me. I missed this here. Okay. Oh, okay. I don't need to ask the question again. Okay. This is running. I'll take a quick look at the chat. And I see someone gave me da, 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 da. Okay, cool. I will try Emiliano's fix just to see, just so I show you guys what it's like to run an LLM locally. And agent is still running, 26. Oof, there you go, real plots. So this is coming in, this is, yeah, this is perfect. And again, same thing. Let's, perfect. Not going to dig into the details, but this is where agents really shine, right? Like this is obviously something an LLM alone cannot do. It needs to be augmented with tools, at the very least, to produce these type of outputs. But it actually did it, right? It gave me some EDA, very interesting EDA on this CSV that I've yet to take a look at. Okay, pretty reasonable, just 3 columns, time series data. But now I get all these nice inputs like correlation matrices. Do I need that? I don't know, but whatever, I have it. Distribution plot, that might have been one of the old ones. Histograms. So this is where you see, okay, it looks interesting, but I think some of the plots are kind of meaningless. Like what the heck is a histogram of searches? Not really meaningful to me, but so be it. But you could take this and keep expanding it and keep expanding it and basically just create your own data analyst, right? This is where a lot of companies are seeing the efficiency advantages of these agents. Like, okay, you keep augmenting them and you keep making better agent systems, and you can get really good outputs that used to maybe take days or a day, and you get it in a minute or two. Let's try model this. Trust remote code equals true. Okay, let's try this code from Emiliano. So hopefully, just to maybe put a thumbtack on this was kind of a end-to-end, what is an agent, most simple implementation, all the way down to, okay, how do we get it to read a CSV and produce something useful for us? What is it actually doing under the hood, right? What is tool calling? What does that actually look like? And then hopefully now, let's try this. We don't need to eval it. Oh, I see. Okay, so this is going through Torch instead of VLLM, which could work, but I don't know if I have Torch easily accessible. And one last thing I can show, since someone asked about MCP while we finish up. I did have a section to use MCP. This is kind of blown up as a term in the last few months. I think the overall thing here is just it's a way to standardize tool usage. If you guys notice, when I created this agent class, not only is the agent running on my client, right, locally, but so are the tools. And I have to author the tools myself. But tools are just functions. So why can't they just kind of import and use other people's functions that they've already spent a lot of time writing and have great ones? And B, why do I need to couple that my tools and my agent must run, uh, let's say, on the same environment, right? Why do they both need to be client side? Shouldn't I just be able to do some API request to a tool like, hey, I want to call tool A with arguments B, go send that to some server. Server is going to do some processing, give me the output of that tool. Cool, now it can keep going. And in general, it's just a better framework to build LLMs and agents that way. So MCP kind of standardizes this, standardizes how we author tools, and how we deploy tools and servers. Very useful. One thing I just did want to show is one website I found is Composio. They have a bunch of different MCP tools that they make available. In this example, I thought I had the Composio URL here, but I guess not. No worries. Composio tools. Cool. Uh, exactly. And actually, I might want MCP tools. Perfect. So yeah, this is basically where I got things. Let's say you want GitHub integration or you want Google Sheets integration. Great. They've already authored a tool to basically handle this integration for me. I can kind of just copy the URL, which I did. Let's just skip through that. Great. They are running it. They're giving me the server. I don't need to actually run that tool myself. They are handling it for me. All I really need to do, and actually the agents SDK kind of lets you use these hosted MCP tools, Model Context Protocol, if I didn't already explain that, paste in my unique that I just generated URL and created this Sheets wizard. So first, let me author everything before I run. Unexpected URL. So what argument does it expect here? Let's see. Tool config. I haven't used this one. So, you know what? Same thing. Let's try again. Use OpenAI agents SDK to fix this. Isn't that exactly what? I might have to import this, which is a different class, and I haven't installed that. Um, but anyway, we basically have 2 minutes left. I'm not going to get into the details of executions, but what this should let you do is actually let your LLM go right to some Google Sheets that you have deployed somewhere else. And you can imagine how these integrations can keep growing, where, okay, maybe I want to integrate with now my GitHub, so it can actually write and read my repo. Maybe my Slack, so it can read my messages between my team. Maybe I can give it access to Google Calendar so the LLM can create calendar events. And there's hundreds of these to really increase all the different kind of things, improve all the kind of things that your agent can do. That's where it gets super powerful. But I'll kind of leave it there. I think we went through a lot. Hopefully, that was very informative for a lot of people or a good review for others who are more expert level. Uh, and yeah, feel free to connect. Feel free to add me on LinkedIn. And yeah, hope this was helpful.
Thank you, Sammy, for the presentation.
I
Uh,
actually didn't notice my screen was like all the way up here the whole time.
and
So
a
sorry
lot
if my face was not the
people
center.
more focus on the presentation. It was great. So as I mentioned, we're going to launch 6 weeks mini boot camp on AI agents. We go above and beyond. It'll be really helpful. Just really like we'll be announcing next couple of days, and you just wait that announcement from us and try to register. We'll have a limited space, and then we'll hope to see you there. Thank you, Sammy. Uh, Bye, everyone. Have a good day. Bye.
Cool. Thanks, everyone. Take care. Bye bye.